All right, 11.4. So we're gonna go right into 11.4 here today. Proportional partitions. Okay, so basically we're gonna talk about when you have something and you're looking at different proportional ways. Okay, first thing you're gonna talk about is mainly you're gonna deal with parallel lines, lines that are parallel. So the first theorem that they give you here is a side splitter theorem, and not one that makes you laugh. All right, but when it splits the sides, okay? So it says this: a segment parallel to one side of a triangle that intersects the other side divides those sides into proportional parts. In other words, if I have a triangle and I draw this line and they are parallel, then what it does is it divides it into 4 parts, right? And these are proportional. So if I was going to set up an equation, it would be x over y equals a over b. Okay, because the x and the a and the y and the b are proportional parts. Does that make sense to everybody? So let's do a problem, make sure we all understand. So first one, basically side splitter, and it's not a funny one. It's just, it just divides it in half, okay? So let's draw this here. 7.2, 4.8, 10.6, 10.8, sorry. So now, how would we find this last section? So we're gonna go ahead and set up our fraction. 7.2 or 4.8 equals 10.8 over x. Cross multiply, right? Okay, so remember I told you if you can ever reduce top and bottom, do so, okay? Just be smart about it, okay? But you don't have to, okay? So if you don't, it's gonna be 7.2x equals 4.8 times 10.8, okay? So 4.8 times 10.8, all right? Divide by 7.2. That gives me x. Now, what do we got? How can we solve? Okay? Well, we know this. I'll tell you this. We know this. 8 goes into this 6 and 9 times. And then 9 goes into this 12 times. Okay? So your answer is 7.2. But if you did it on your calculator, you would see that it comes out 7.2. Okay? So all you're doing is, once again, still straight proportions. The second one, the converse of that. What's the converse of that? Is if you have proportional sections, then what do you know about these two lines? They're going to be what? Parallel, okay? And that's all. So if they're proportional, then they're parallel. Just remember that as we go, okay? So you can check for parallelism by checking to see if they're proportional, if they give you all 4 sections. All right? Now, the next theorem that goes right along with this, it's another theorem, and basically it says this. I'm going to read it for you. It says, 3 or more parallel lines divide transversal into proportional sections. So, in other words, if I have okay, so let's say I have all those and they are parallel to each other, then what do we know? Then all of those sections, all the sections are going to be proportional. That's all it's saying. So it's just saying that you can go further than just one set of parallel lines. It can be multiple sets of parallel lines. So just keep that in mind as you go in and do your homework. You're going to have multiple sections, okay? Multiple things. So like if this is, let's say this is x, y, w, a, b, c, w, it's x over a equals y over b, right? Or you could have x over y equals a over b, okay? You just have to decide which one you want to go with, And you gotta be consistent. Be consistent. All right, the last one is triangle angle bisector theorem. So this is the next theorem you need to know. The bisector of an angle in a triangle divides the opposite side into segments that are proportional. So all this one is saying is that if I have an angle bisector, so in other words, if I have a triangle and I draw an angle bisector, first off, class, what's an angle bisector? Cuts the angle in half. If I cut that angle in half, then this and this are going to be proportional. They are going to be proportional, okay? So all they're saying is if I have that, then that's going to be the proportion. So let's do a problem for 3, okay? X, Y. Okay, so what it looks like right there, right? So what would it be? What would that answer be? And how would we solve? Okay? All right, so actually I'm gonna redraw this. I didn't draw it right. All right. Okay, so it's an angle bisector is 45, 45, right? Now, let's solve for this, X and Y. So if they only give you that information, how would you go about solving it? So you start with what? We need to find this distance, right? Which is the Pythagorean theorem. A squared plus B squared equals C squared. So 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. 25 equals C squared. C equals 5. So we know this side is 5. So, class, if I want to solve for X, then what is Y? It's going to be 5 minus Y. So those are your two things. Does everybody understand that? Okay. So X is 5 minus Y, so therefore Y equals Y. All right, so now you have to do that because when I set up my proportions, 3 over 4 equals, so which one goes with 3? Y. Good. And which one goes with 4? Would be X, which is 5 minus Y. Cross multiply. We have 4Y equals 15 minus 3Y. Now what do I do? Add 3Y both sides. And you're left with Y equals 15. 7Y equals 15. Divide by 7, divide by 7. Y equals 15 over 7. Okay? So once you have that, you can plug it back in and you can solve. And 5 minus 15 over 7 is going to give you basically what? 2 and 1/7. All right? 2 and 1/7. Okay, so if you plug this back in, Y equals 5 minus 15 over 7, which is, by the way, 35 over 7. Okay, so X equals 20 over 7, which you can leave it in that form, right there. All right?